Good morning, friends. Today we'll be continuing the topic spherical mirrors. A student has focused the image of a candle flame on a white screen using a concave mirror. So, there is a question. The length of the flame, focal length, and the distance are given as 1.5. That is the length, focal length as 12, and distance as 18 centimeter. Now they are asking to find some of them. First one is distance of the image from the mirror. Second one is the length of the image. So now we will be discussing it detail. So first you have to write what is given in the problem. So first we are entering the data. It is a concave mirror. So it should be, all the terms should be in negative. So the first one, the image distance is given as 1.5 centimeters. So I wrote it. Focal length is equal to 12 centimeter. Since it is a concave mirror, I took it as minus. U is equal to 18 centimeter. Once again, it is negative. So I entered the data which is being given. So the first, whenever you are starting a problem, enter the data. That is the first thing you have to make. Now we are going to see what they are asking. The first part of the question is, they are asking to find what is V. So V is nothing but the image distance. So by using the formula 1 by F is equal to the formula for mirror 1 by V plus 1 by U. So 1 by V is equal to 1 by F minus 1 by U. So it is 1 by minus 12 minus of 1 by minus 18. So here you can take the LCM or just cross multiply. I am taking the LCM. So it is minus 1 by 12 plus 1 by 18. I take the LCM as 36. So it is minus 3 plus 2 by 36. So now 1 by V is equal to, we are calculating it as 1 by 36, that is minus 1 by 36. So V will be 36 centimeters. V is equal to 36, taking the reciprocal, 36 centimeters. So first I enter this. Now you will be seeing that the F, U as well as V, everything will be in negative sign, whereas the height of the image will be in positive because we are keeping an erect object. So it is in positive. So 1.5 will be in positive. All the remaining terms will be getting it as negative. Now this is the first part of the question we have completed. So since it is at negative centimeters, you can tell that the distance of the image from the mirror is 36. That is, the negative sign indicates that the image is formed on the same side of the mirror. The image cannot go beyond it. So since the image is formed on the same side of the mirror, we can conclude from the negative sign. So that is the next part we are going to discuss. So as the distance is 36 centimeter, the negative sign indicates the image is formed on the same side. So that is the thing we are observing from minus 36 centimeters. Now the second part, they are asking to calculate the height of the image. So what is the height of the image? So magnification M is given by height of the image by height of the object. So hi by ho I take it over, which is nothing but equal to, since it is a mirror, we are getting it as minus v by u. That is a magnification formula. So m is equal to hi by h object, which is nothing but equal to minus v by u. So you should be careful with. So therefore hi equals to, so cross multiply it, minus v by u into ho, that is height of the object. So now I am substituting the value, the negative sign already in the formula, I take it as it is. Then v is equal to minus 36. Then what is u? So u from the previous case, that is nothing but minus 18. V is equal to minus 36. I am including those things. So minus 36 by minus u is 18. So those two minus getting cancelled. So into h naught is 1.5. So those two things will be getting cancelled and the negative sign will be there. So hi will be equal to, so when I am cancelling it off, the negative sign, since both there are three negative signs, 2 will get cancelled, 1 will be there. So the end product will be having a negative. Minus, when I am substituting it, I get it as 3 centimeters. So the length of the image which is obtained is 3 centimeter. From this we can conclude that the mirror and the flame is reduced to 10 centimeter. No image is formed on the screen as the object lies between the focus and the pole of the mirror. So a virtual image behind the mirror is obtained as shown in the figure given below. So we are getting an virtual image. That is why we are representing it as a negative sign. So now we are going to see how we are going to draw this particular diagram, ray diagram. So most of you have asked how we are going to draw it. So from the given data, we are going to draw the ray diagram. So first we are making sure what are the points which are being given. So from this we are inculcating it. So now we are going to see how the image is formed. So first it is a concave mirror. So I drew a concave mirror. So first thing I am doing it. So I am shading on the outer side to represent it as a concave mirror. So a line joining the center of curvature, focus and pole, we call it as the principal axis. So I drew that particular line also. Now, as per the question, we have the image exactly placed between F and P. So I am drawing F and 2, and then C must be twice the distance of F. That is 2F or C, or center of curvature we can tell. So here from the pole, so since the question is M is equal to minus 3, that is we will be getting an virtual image, that is formed inside the mirror. So the object is placed between F and P. So I am drawing a straight line. I am placing an object exactly between F and P. So usually there will be two lines originating from the head of the line, that is head of the image. First line will be parallel to principal axis. Second line will be passing through the pole. So these are the two image lines which are forming. The line which is parallel to principal axis, after reflecting, passes through the focus F. That is what I have drawn. So first thing is, first it parallel to principal axis. So it is after reflecting, get back to the pole. So here from the pole, another, it will be reflecting back with the same angle. So if the incident ray is 30 degrees, from the pole it will be 30 degrees. So that is very important. Now I am going to draw a line passing through the pole. So after reflecting, this line will come back. So to make it clarify, so I am extending the line to a certain point. Now I extend the from the focus, the line I am extending it to a certain length till it meets that point. So after at that particular point only the virtual image is obtained. So from there, since it's a virtual image, I drew it by a dotted line. So after reflecting, the image will be coming in this particular direction. So AB is the length of the image and A dash B dash is the length of the image. So after reflecting, the line will come outside. So this is the end of the diagram. So make sure that you give the data and do it. The next one, we are going to another problem. An object is 4 centimeter in size, is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. So what we are going to calculate? The first one we are going to calculate is the at what distance from the mirror should a screen be placed to obtain a sharp image. The first part. And the second part is find the nature and the size of the image. That is the second. And the final one is nothing but we have to draw a ray diagram to show the formation of the image in this particular case. So this is the question. So we are going to see it one by one. So the first one is the distance, that is V, we have to calculate. So that is the next problem we are going to discuss. So we are writing, we are just taking down the data which is given here. So it is given as a concave mirror. So we are inculcating the points. So U will be 25 centimeter, which is negative. Focal length is given as 15 centimeter. Since it is a concave, it is also negative, minus 15 centimeters. So the signs will not be mentioned in the formula itself. So then the question they will be giving only the values. You must be careful when you are entering the sign. So follow the Cartesian sign convention which I given in the previous video. So H0, that is height of the object, is equal to 4 centimeters. Now the same formula we are going to calculate for 1 by V. So 1 by F is equal to 1 by V plus 1 by U. So that is the formula of a mirror. From this I rearrange for what is 1 by V. Therefore 1 by V is equal to, so 1 by V equal to 1 by F minus 1 by U. So I am substituting the values. So it is 1 by F, so it is 1 by minus 15 minus 1 by minus 25. I take the LCM as 75. So the LCM will be 75. So it is minus 2 by 75 getting, and I am substituting it, I will get it as minus 2 by 75. Therefore V is equal to 75 by 2, which is nothing but 37.5 centimeters. So we are getting it in negative. This shows that the screen should be placed in the mirror, that is on the same side of an object at a distance of 37.5 centimeters from the mirror in order to obtain a sharp image. So that is the first we have calculated. Now the second part is we have to calculate the magnification. So the terms you should be very careful. So V is equal to minus 37.5 centimeters. So now we are going for the second part of it. Next one will be the magnification, which we are going to find. So you know the magnification formula. Second part, M is equal to Hi by Ho, which is nothing but equal to minus V by U. So from this, height of the image is nothing but Hi is equal to, so just as we have done in the previous problem, Hi is equal to minus of V by U into H0. That is Ho into V by U. The negative sign will be there. I am substituting the value for H is given as minus 4 into minus 37.5 by minus 2.5. I am skipping out the calculation, so we'll be getting it as 6 centimeters. So the answer will be negative. So u is equal to minus 6 centimeters. Therefore the size of the image is minus 6. So hi is minus 6 centimeters. So hi is equal to, that is height of the image is greater than height of the object, that is 4. So the image is enlarged, and negative sign shows that the image is real and inverted. So hi will be greater than ho. So we can tell that the image obtained is real and inverted. So that is the next part. Now the third part is nothing but the ray diagram. We are going to see that how we are drawing the ray diagram. So from the data which is given, we are going to draw the ray diagram. So it is a concave mirror. So first I will draw the concave mirror. So you need not draw it for every case. If they are asking it, you have to draw, because as per the problem they will be allotting marks for it. So I'm drawing the concave mirror. That is the first part. So the principal axis line I drew. So focal length is f. Center of curvature, or twice the focal length, is 2 times of it. You should be careful with. Now the object is placed exactly between C and F. So it will be somewhat between C and F. So HO. So there will be 2 rays, one parallel to principal axis. The ray which is parallel to principal axis will exactly pass through the focal length. Another ray which is passing through the pole. So that is it. So the first 2 rays I am drawing it. The line which is exactly parallel to the principal axis will pass through the focals, that is F. I drew it. The line which is incident on the pole will be experiencing the same angle of deflection. So the point where these 2 lines meet, there an image will be formed. So we will be getting the same angle over there. So from there you will be drawing a straight line. So you will be seeing that the size of the image obtained will be in the opposite direction, and also it will be inverted and enlarged. So that is how we are representing it. It is a real image, so I'm just not drawing it by a dotted line. Now I'm marking out the points. So first it is US 10 centimeters. So first the focal length is 10 centimeter. I included that. The next one is F I have written as 10 centimeter, U is written as 25 centimeters, and the V distance as 37.5. So from there I draw the V distance, which is nothing but equal to 37.5. So this is how we are drawing the ray diagram. So make sure that you try to include all the data given in the ray diagram. Thank you.